last section is about the normal curve. First thing I need to do, think about what the normal curve is. It is sometimes called the bell curve. It's kind of bell-shaped. You have the x-axis, and the highest point is the mean. We're going to use a lowercase Greek letter mu for the mean. Mu is how you say it. And we're going to use a lowercase Greek letter sigma for the standard deviation. We say it sigma. Okay. So if we have a negative standard deviation, that means we're below the mean. A positive one is above the mean. Each member of the population has what's called a z-score. This z-score is their individual value, which I'll call x, minus the mean divided by the standard deviation. So if their individual value is less than the mean, x minus mu will be negative, and their z-score will be negative. If their individual score is higher than the mean, then they'll get a positive number. If it's actually equal to the mean, your z-score will be 0. So let's do an example. Say the mean height of the population of a certain school is 50 inches, with the standard deviation being 5 inches. Make it 6 inches. Okay, let's say Pat is 43 inches. Terry is 59 inches. Let's find their z-score. Pat's z-score is going to be 43 minus 50 divided by 6. If you put the whole thing in the calculator at once, remember you need to put in the invisible parentheses on the numerator. I'm going to do it in part. 43 minus 50 is negative 76. When we get our numbers, we're going to round to the hundredths place. So I'm going to put negative 1.17. Negative 1.17. And I'll just close my calculator by accident, so let me get him back. And to make him small, not to close him. Okay, that's because Pat's z-score is lower than the mean. That's why it's negative. Terry's z-score, on the other hand, is 59 minus 50. 9 minus 0 is 9/6. 9/6 is 1.5, but we are going to make it to the hundredths place. 1.5. We have a chart that will tell us the percentage of people, or the percentage of the population, it could be something other than people, animals or cars or whatever, percentage less than a particular z-score. So if you look at the charts, and if you're actually doing a problem in my math lab, it'll either have a portion of the chart in the problem, or it'll have a link that you can click on and get to these charts. Notice the z-scores are down the left. Starting, the smallest one is negative 3.40. You look at the second number up here in order to get the hundreds place. So negative 3.45 would be right here, because there's negative 3.4 and there's 5, and that would tell me 0.0003, which if I move the decimal is 0.03% of the people are below that standard deviation. If I look at a number over here, say 2.14, here's 2.1 plus the 4, 2.104 would be this number, 0.9838, move the decimal. So 98.38% of the population is below a standard deviation of 2.1. So this tells you where they are lower than or less than. They sit up here, left of, and left is less than. Okay, so let's do a couple of examples. See, I said the mean was 50 and the standard deviation was 6. So let's stick with that. The mean, forgotten it already, that's bad. The mean is 50 and the standard deviation is 6. So let's go with that. And I want to find the percentage of the population shorter than or less than shorter than 63 inches. So first of all, I need to find the z-score. 63 minus 50 over 6. So that's going to be 13 divided by 6, 2.17. So then I'm going to look up in the chart for 2.17. Here's 2.1. Here's the 7. So 0.9850, which is the same as 98.5%. So 98.5% of the population is shorter than 63 inches. Particular school. So what if I want to do greater than? Find the percentage population taller than or greater than. Well, first find the shorter than and do 100% minus the percent shorter than. So in this case, percent minus 98.5%, 0.5, 1.5%. So shorter than, you read right from the chart. Taller than or greater than, you do 100% minus what's in the chart. One more type, that's the between. So once again, make mu 50 inches, sigma 6 inches. Let's find percentage of the population. Between 42 inches and 56 inches. So let's first find the z-scores. So the first one is 42 minus 50 over 6. The second one is 56 minus 50 over 6. So this one turns out to be negative. And this one turns out to be positive. 86 is 1.33. And 66 is 1.00. So those are the z-scores. When I look these up, I'm going to subtract them because I want what's between them. So if I look them up and I find from weighing no pounds or whatever is up to 1.33, and then I look up, should be negative, and then I look up to 1, I'm going to find the difference in between. So first of all, I need to look up 1.33, negative 1.33 in the chart. Maybe it'd be easier just to put the chart again. Negative 1.33. There's negative 1.33. So that's going to be 0.0918, which is 9.18%, or below 42 inches. And now let's look up 1.00. So 1.00 is 0.8413. And that's going to be 84.13%. So 84.13% of the population is shorter than 56 inches. 9.18% is actually shorter than 42 inches. We don't want those that are shorter than that, so we're going to subtract those away. 84.13% minus the 9.18%, 4.13 minus the 9.18, so you have 74.95%. So the less than, you look up from the chart, the greater than is 100% minus the percent of the less than. And if you want between two numbers, you look up their percents and then subtract. Remember, the percents will always be positive. The z-scores could be negative. That is the final topic for the course. So finish your homework 12. Take your last quiz, your last test, your final, and you will be finished with this course altogether. Good luck in all your future courses and wherever you go from here.